So our today's topic is free space management. So in free space management, first of all, the system keeps tracks of the free disk blocks for allocating space to files when they are created. Also, to reuse the space released from deleting the files, free space management becomes crucial. And the system maintains a free space list which keeps track of the disk blocks that are not allocated to some file or directory. So here we can see an example of free space management. So first of all is bitmap or bit vector. A bitmap or bit vector is a series of collection of bits where each bit corresponds to a disk block. The bit can take two values, that is 0 and 1 binary values. 0 indicates that the block is allocated and the 1 indicates a free block. The given instance of disk blocks on the disk in figure number 1, which is shown below, where green blocks are allocated, can be represented by a bitmap of 16 bits. So this is a combination of 0 and 1, and all the 1 to 16 blocks are given in figure number 1. These are the advantages of bitmap or bit vector, whereas simple to understand and finding the first free block is efficient, and it requires scanning the words, a group of 8 bits in a bitmap for a non-zero word, and a zero valued word has all bits 0, and the first free block is given then found by scanning for the first one bit in the non-zero word. And the block number can be calculated as, so here is the formula to calculate the block number, whereas number of bits per word multiplied by number of zero values words and plus offset of bit first bit 1 in the non-zero word. So this is the formula for non-block block number calculation. So in figure number 1, we can scan the bitmap sequentially for the first non-zero word, and the first group of 8 bits, that is 0000 1110, constitute a non-word since all bits are not 0. After the non-zero word is found, we look for the first one bit. This is the fifth bit of the non-zero word, so offset is equals to 5. As we can see the formula where the values were put it in the formula, and we have the block number, that is 5. 8 is multiplied with 0, and whatever the result, we have to add 5 in that particular value. Another type of free space management is the linked list. In this approach, the free disk blocks are linked together, that is, a free block contains a pointer to the next free block, and the block number of the very first disk block is stored at a separate location on disk and is also cached in memory. So in the previous figure, that is figure 2, the free space list had points to the block 5, which points to block 6, the next free block, and so on. The last free block would contain a null pointer indicating the end of free list, and a drawback of this method is the input output required for free space list is traversal. As we all know about, traversal is the visiting of each and every block in my disk. So the last one is grouping with counting. This approach stores the address of the free blocks in the first free block. The first free block stores the address of some, say, n free blocks. Okay. After that, out of these n blocks, the first n-1 blocks are actually free, and the last block contains the address of next free n blocks. Here is the advantage of this approach is that the addresses of a group of free disk blocks can be found easily. And in the counting approach, it stores the address of the first free disk block and a number n of free contiguous disk blocks that follow the first block. And what will the output after that? Every entry in the list would contain what? Address of first free disk block, and a number n. Okay, and for example, we can also consider in this the figure 1, the first entry of the free space list would be address of block 5, 2, because two contiguous free blocks follow block 5. So this is all about your free space management. Thank you.